Well, hi there sports fans, and welcome to lesson 2 from Physics 12. And in today's lesson we're looking at motion with several constant speeds. So this deals with an object that's in motion and that may be moving at different speeds at different times or different directions. And so we'll look at how we deal with those kinds of problems. First of all, let's talk about average speed and average velocity. First of all, average speed is the total distance that an object moves divided by the total time that it takes for that object to move that particular distance. So d then is going to be total distance, and t is going to be total time. All right. Now, average velocity, on the other hand, is the displacement vector divided by the total time. So the displacement vector is the final displacement of the object, final displacement, and that is, again, that's from just simply the starting point to the finishing point. Okay, so once again, the displacement of an object is just simply the vector from the starting point to the finishing point, and it doesn't concern itself with what happened in between. That's not what we're concerned about when we talk about a displacement vector. It's just simply from the starting point to the finishing point. T, again, is just going to be the total time in this formula right here. Okay, so average speed and average velocity, once again, they will be the same except when you have a change in, and can you guess it this time? Yes, in direction. So they'll be the same unless there's a change in direction. Now, when you're dealing with these kinds of problems, when you have a change in speed or direction, or velocity, then you have to divide the problem up into different phases, whether it's 2 phases or 3 phases, whatever the case may be. And that's how you need to deal with these kinds of problems. So we'll look at an example to see how this works out. So here's our example. An object moves east for 15 minutes at 60 kilometers per hour. It then moves west for 100 kilometers at 80 kilometers per hour. So find the total time, find the average speed, and find the average velocity. And as you can probably guess, the average speed and the average velocity are not going to be the same. Okay, so let's go back to our basic equations here. So distance is speed times the time, and again the displacement is the velocity times the time. The average speed, which we talked about right at the very beginning, is the total distance divided by the total time. Average velocity, however, is the final displacement vector divided by the total time. Alright, so let's see how that's going to work out for this particular example. So phase 1, as you noticed, I've divided it up into the 2 phases here because we have 2 phases in this particular problem. And in phase 1, we're told that the object is moving at 60 kilometers per hour to the east, and that the time for that phase is 15 minutes. Now we're going to convert that to hours because we're dealing with kilometers per hour. Now, careful when you change from minutes to hours, because 15 minutes is not 0.15 hours. It's 0.25 hours. 15 minutes is a quarter of an hour, or 0.25 hours. And that's because the time is based upon a 60-minute hour and a 60-second minute, not 100. So be careful when you're changing these from minutes to hours. 15 minutes is 0.25 hours. And then we have the velocity vector, and that would be 60 kilometers per hour in the I direction. So in the positive I direction, and we talked about that, the I symbol last time, meaning in the X direction. Again, the time then for this was 0.25 hours, which we just mentioned. So the distance then, let's look at the distance for phase 1. The distance is just simply going to be 60 times 0.25, and that works out to 15 kilometers. 15 kilometers. The displacement also is 60 times 0.25, and we'll write it this way here, 15 kilometers in the I direction. So it's positive 15 kilometers in the I direction here. Okay, so that's that was the unknowns from phase 1. Now from phase 2, they're giving us a little bit different information here. The speed in phase 2 was 80 kilometers per hour, but to the west. And so the speed then is 80 kilometers per hour. But when you're talking about speed, you're not worried about direction, so it's still going to be positive. Velocity, however, does concern itself with direction, so this is going to be in the negative direction for velocity. So the velocity then will be minus 80 kilometers per hour in the I direction or in the X direction or to the west. So you've got to watch out for that, because the velocity now is indeed going to be negative. And so that also means that the displacement, you're told that the object moves 100 kilometers in the western direction. So therefore the displacement will also be negative, and that'll be minus 100 kilometers, and again in the I direction. So that was the information that's given. So we need to find the time for the second phase, which is not given, but we can find it from the information that we have. So the time then we'll just find from d2 divided by v2. So the time for phase 2 will just simply be, so this is going to be, make sure I get the right numbers here, and that's going to be 100 divided by 80, 100 divided by 80, and that'll be 1.25 hours. So 1.25 hours. And also, now, if we look at the vectors, okay, watch this. So the displacement vector is minus 100, so minus 100. The velocity vector is minus 80, so minus 80. And guess what? We also get positive 1.25 hours. So as long as you've got all the right signs, the pluses and the minuses, all of them will work out correctly if you're careful with the pluses and minuses as you're working through the problem. And so again, we get a positive number for time, which is what we expect. If you get a negative number for time, you know that something's wrong, so you better go back and check your pluses and minuses there. Okay, so let's finish this up here. So the total time then is going to be T1 plus T2, and that is going to work out to, make sure I got the right numbers here, that'll be 0.25 hours plus 1.25 hours. Right, so T1 was given at the very beginning, 0.25 hours. T2, we just figured that out, that's 1.25 hours. So that works out to 1.5 hours. Okay, so the total time then is 1.5 hours. Okay, let's just go through the numbers again. So T1 was given as 0.25, and T2 is 1.25 hours, so the total time is 1.5 hours, which we just did. Okay, now let's look at the total distance. Distance is going to be d1 plus d2, and d1 I think we've calculated that at the very beginning, and that was 15 kilometers. And d2 was given, which was 100 kilometers. So D1 plus D2 then is going to be 115 kilometers. And so we know what the time is. So the average speed then is going to be the total distance divided by the total time. So 115 divided by 1.5. And that works out to 76.7 kilometers per hour. So the average speed that this object moved was 76.7 kilometers per hour. Okay, now let's look at average velocity. So here we again we have the final displacement or total displacement, and we determined that the first displacement, or the displacement for the first phase, was 15 kilometers. And we were given that the displacement for the second phase was minus 100 kilometers. So therefore, wait a little bit, the total, or the final displacement vector, is minus 85 kilometers in the I direction. All right, so its final displacement is a negative number. So, in other words, from its starting point, it ended up west of where it started from. So, its final position was to the west of where it started from. Again, the time we talked about was 1.5 hours. And so the average velocity then will be the final displacement divided by the total time. And so the average velocity then was minus 56.7 kilometers per hour. And so as you can see then, average speed, average velocity can be very different things if you have that change in direction. If there wasn't a change in direction, these would actually be the same. But because of the change in direction, they are indeed different. Okay, so that ends the lesson for today. And this gets to be a little bit tricky. There's some other examples we'll be doing in class. So then we will carry on from there.